We started just briefly talking about our 5-number summary, and today we're going to finish looking at this and talk a lot about how to construct and interpret box plots. Okay? Now, you may have dealt a little bit with box and whisker plots in the past. Okay, and you can put your computers away because you don't need those now. Okay. But whether you have or not, one thing that we're going to emphasize here is interpreting, making sure that we understand what these plots are telling us. Because a model is no good if we can't interpret it. The other thing I'll mention is that with the new SAT, there is an increasing emphasis on statistics and also data analysis, reading graphs and things, and making interpretations. All right, so this will help for that as well. Okay, so let's talk about our 5-number summary. Can anyone remember any of the parts of the 5-number summary? I know we just barely talked about it. Okay.
Mean and the first.
Okay, we had the median and we had the first quartile. Okay.
And the third quartile.
Good. In the third quartile, and there were 2 more values here. Alexi?
I'm not sure. I think it's the mean of the first quartile, mean of the second quartile.
No. No, or the first quartile and the third quartile are just a value. Okay. Michelle?
Maximum, minimum.
The max and the min, okay? The highest and lowest scores, okay? So, we have here a 5-number summary. The range is not actually part of the 5-number summary, but it does have it does involve 2 of the values that are part of the 5-number summary, okay? The max and the min. And then we will look at the first quartile, this Q1. That's another part of our 5-number summary. It's greater than 25% of the data. Remember, someone made the connection, which was good, to percentiles. It's like the 25th percentile. But we said it's the median. Oh, and that didn't save. Okay, it's the median. There's a better way of wording this. Of the data that lies below the median of the set. Okay? It's the median of the data that lie below the median of the whole set. We'll illustrate that here in a moment. I will go ahead and mention we did have the median, okay, which we've already studied, but the median could also be called the second quartile. All right, now we don't refer to it that way usually. But the key here that we want to make sure we understand is this is the value that is greater than 50% of the data. Okay? And the reason why I include that here is because this is a second part, or I'm sorry, a third number in our 5-number summary. Okay, so we have the min, the first quartile, the median, and then we had this third quartile, and then we have the max. Okay? All right. So that's our 5-number summary. Now the third quartile, remember we said is the value that's bigger than 75% of our data. Okay? and it's the median. Okay, notice there are 3 different medians that we have to keep track of here. It's the median of the data that lies above the median of the whole set of data. Okay? And then finally, we have what's known as the IQR, the interquartile range. Okay. And I want to illustrate this here on a number line just to kind of help us picture what's going on here. Okay? So, first of all, we have the min and the max. We have the lowest point, the min, somewhere down here. The highest point is the max, somewhere up here. And this distance between them is our range. Okay? Then we have our median, which is the middle score. Okay? The middle score. Okay. Then we look below the median. Below the median at all of this data, and we find the median of all of that. Okay? And that is our first quartile. Okay, Q1. Then we look at all of the data that is on the right-hand side of our median or above the median, and we find the median of that data, and that's Q3. And this distance right here is what's known as our IQR, the interquartile range, IQR. And to find that actual value, we simply subtract the third quartile minus the first quartile. Okay. So, any question on this terminology so far? So when I say find the 5-number summary, you think min, Q1, median, Q3, max. Okay? Those 5 values. So, what good is our 5-number summary? Well, the 5-number summary is how we construct a box plot or box and whisker plot. Okay? So let's look at it. Here again we have our 5-number summary laid out for us. And then we have an example of a box and whisker plot drawn for us. Well, let's see how we would use our 5-number summary to get this. Okay? First of all, notice in a box and whisker plot you have a number line down below it. Okay? We're not going to draw our box and whisker plot on a number line. We'll draw it in the space above it. Okay? So don't ever draw it on top of the number line. But if I were drawing this and I had my 5-number summary already figured out, the first thing I would do is plot my minimum value and my maximum value as points. Okay? The lowest and highest points. The other 3 numbers I would put on my above my number line as just vertical bars. Okay? The median is here at 6. The first quartile is Q1, and the third quartile is Q3 right there at 9.5. Okay? Once I get those, then I can fill out my box and the whiskers. Okay? So we can simply connect these. Oh wait, hang on. Let me get on the right go. So we connect these, we've got our box, and then from Q1, we just draw a line down to our minimum. That's the lower whisker. Then we draw from Q3 up to our max value, the upper whisker. Okay? So we have the box and the whiskers. Now, the reason for the distinction here is a couple things. Let me make this a little straighter. That's kind of bugging me. All right. First of all, okay, this box represents my middle 50%, okay? Now understand what I'm saying when I say that. The median is the value bigger than 50% and smaller than 50%, okay? But this box right here is where 50% of my data lies. Okay? So we could say that that is our middle 50%. Now that's helpful because, you know, our mean is probably going to be in there, or should end up being in there. Okay? That's where our data is kind of centered around. If we wanted to look at a range where our data is kind of collected in, half of our data is in this smaller range here. Okay? The lower whisker is 25% of the data, but it's the bottom 25%. It's the lowest values. Okay? The upper whisker is the values that have the highest, or the highest 25% of the values. Okay? Now, drawing this out visually can help us make some inferences about our data. For example, what could you tell me about the data in my bottom 25% compared to the data in the top 25%? Just by looking at the graph here, how could you compare the data in that bottom 25% with the data here in the top 25%?
The numbers are closer together in the bottom 25.
Okay, yeah, the numbers in the bottom 25% are closer together. Okay? And obviously then in the top 25% they're spread out a little bit more. Okay? So good, that's a good observation. Notice here with the this from 25 to 50% right here. Okay? And then from 50 to 75%. Notice from 25 to 50% is grouped closer than the ones that are between the 50% and the 75%. Okay? Now, understand here, there's still the same number of pieces of data in each of these quartiles. Okay? You know, if there are 5 people represented down here, there's still 5 people represented here, 5 people represented here, 5 people represented here. It's just the values are spread out more or condensed more. Okay? Does that make sense? All right. Now, what this can help us see is, you know, possibly it might be that there actually was just one person that was really high here, and the others in this top 25% were actually closer. Okay? That's a possibility. It's possible that these could be, you know, kind of evenly spread around, but it's also possible we could have had a bunch of them right here, and then we just had this one guy out here. Okay? So, when you see something like this, it could actually bring up more questions about the data, and that's where we can do some further analysis. Okay? Now, let's actually practice constructing one, and we'll get even more into the analysis later on here. Okay? So let's start with a small set of data. We have 9 pieces of data. And in order to find the 5-number summary and IQR, and then draw a box plot, okay, let's start with the easy stuff, okay? What are the easiest ones? Yeah, could you pass it here, please? What are the easy ones to find? The min and the max, okay? The min and the max. So, if I'm going to write down my values first, 78 and the max is 98. Okay? Then what would we find? The median, yeah, you can't find the quartile 1 or quartile 3 if you haven't found the median yet. So what is the median going to be in this case? 87, yeah. We've got 9 pieces of data. So 9 divided by 2 is 4.5, so that means the 5th one will be our median, okay? So median is at 87. Now we have to figure out quartile 1. What would Q1 equal?
84.
84? What do you guys say? Someone explain to me how they got 84.
Well, between 78 and 87, like including both, there's 5 numbers.
Mm-hmm.
So you just find the median, which is 2 on each side, 84 is in the middle.
Okay, so that's good logic, okay? This is the one part that we really have to be careful about, all right? And it's fine if you said 84, because this is probably the most common thing that people will not quite get right on these. Let's look back at our definition of Q1. Q1 is the median of, what did we not follow here?
Below the median.
Below the median. Okay? Did we use just data that was below the median? No, what did we use?
Median.
We used the median too, right? That's really, really common. People want to do that, but we have to look at, in order to get Q1, we're only going to look at the data that is below the median. So, with those 4 numbers, what's our median?
83.5.
Yeah, there we go, 83.5. We have an even number of pieces of data, so we average the 2 in the middle, 83.5. Does everyone get that?
It's not 84.
It's not 84. Because we're not going to use the median to find the bottom half. We're only using these 4 values. Okay? So when I go to find Q3,
95.5.
there we go. We're not going to use the 87 to find Q3 either. Alright? We're just going to look at those 4 pieces of data. Find the median is halfway between 94 and 97, so that is 95.5. Okay? So, now we can actually construct our box plot. So you'll see here, I have a number line, okay? And guys, when you're asked to draw these, you're not necessarily going to be given the number line with a scale on it, okay? So you might have to construct your own. So here's what I feel is kind of the easiest way to do it. I'll start with my min and my max. So I have 78 as the min. I'm just going to mark that on my number line, and I put the point up here, okay? And then my max was 98, so I'm going to mark that on my number line. I'm going to put the point here. Then I need to kind of construct a decent scale. So since there's a difference of a range of 20 here, probably going by 2s would be good. Okay, so I'm going to go right in the middle. Right in the middle of these would be at 88. And then I can go 90, 92, 94, 96. Here's 78, 80, 82, 84, 86. And, you know, do your best to space them out evenly. Alright, so now I have my min and my max. I have my number line with a good scale to use. Now I just need to plot these other values in my 5-number summary. Okay? So 87. 87, we're going by 2, so 87 is going to be right about here. And I'm just going to put a vertical line there, because that's part of the box. Q1 is at 83.5, so here's 78, 80, 82, 84. So 83.5 is going to be about 3/4 of the way between those two. So I'm going to put a vertical line there. And then for Q3 I have 95.5. So here's 88, 90, 92, 94, 96. So 95.5 is going to be right about here. And I put a vertical line there as well. Okay. Now I just need to draw my box and the whiskers. Okay. So I'll draw the box here. And I'll draw the whisker going from Q1 out to my min, and my upper whisker going from Q3 up to my max. And there is our box plot for this data. Okay? All right. Now, what's our IQR?
13 or 12.
Okay, it's going to be 12. 95.5 minus 83.5, so that's 12. That is this distance right here, right? IQR equals 12. What are some things you observe? What do you see when you look at this box plot? What do you see?
A box.
Okay.
Wait, this box or any box?
No, you look at this box plot. What do you see?
One side is bigger.
Huh?
The right side is bigger.
Okay. This right side of the actual box is bigger. So what does that mean about the data in that part of the box?
The median is close to first quantile.
Okay. The median is going to be closer to Q1 than it is to Q3. That's correct. 87 is closer to 83.5 than it is 95.5. All right. So since this box is bigger, what does that mean about the data there?
More spread out.
It's more spread out. Okay. What about the data in our top 25%? It's really close together. We have a really short whisker here. So that data's close together. Okay, and you can actually see that here. It's 97 and 98. All right. Whereas here we have from our median 87 up to 94, 95.5. Okay. You know, 91 is a ways away from 87, and then those are 3 apart as well. So they are more spread out. Okay, and even with a small set of data here, we can make these observations. What this allows us to do is, even if we didn't have all this data, or let's say we had this, but you know, we had 50 pieces of data rather than just 9, we could very quickly look at it and tell some things about the different the different parts, okay? I can tell here that my bottom 50% was kind of grouped a little closer together than my top 50%, okay? You know, so again, there's a few different inferences that we can make. Now, take a look at this box plot, just to highlight where the points are. This is at 25 exactly. This is at 55 exactly. This is at 70. This is at 85. And then this right here is at 98. Okay? So take a look at the questions. These aren't meant to be super difficult, but think it through and write down your answers. Okay? Using this box plot, how would you answer these questions?
Do we work together?
No, just do this on your own. These actually should go pretty quickly. Okay, let's think through these. Okay, the highest mark was. Alright, these are not all that hard at first, at least. Highest is 98, the lowest was 25. Okay, half of the class scored a mark greater than or equal to 70. Okay, 70, that median, that's what that is. Half of it is at least that. Okay, so half the class got at least a C minus. Alright, the top 25% of the class scored at least how much? 85, that's our Q3. Okay, 85. And then the middle half of the class had scores between what and what?
55 and 85.
Okay, 55 and 85. Remember, the box represents the middle half. Okay? The box is the middle half. So we're between 55 and 85. Okay? Now, what is our range? 73. 98 minus 25. The max minus the min. We've got 73. And then what's the IQR? 30. Okay? 85 minus 55. We've got 30. Okay? Now, what we could do with this, let's say this was an actual test and we intentionally had made it really hard, okay, to try to separate, you know, so if we make it too easy, then a lot of people get really high scores and you can't really distinguish between how they're doing. Or, you know, everyone's kind of clumped together closer. This is what they do with like the AP exams and the IB exams. All right, a passing score on the IB exam, you know, to get a 4 is, you know, you're getting like a 50% on the exam. Sometimes even lower, depending on the year. Okay? So you're passing with a 4, only getting half of the stuff right. Okay? They intentionally make it hard, otherwise they'd have a bunch of people getting perfect scores and then they'd have too many 7s. Alright, so they intentionally make it harder in order to distinguish between those extreme values. Okay? So, if we wanted to then normalize this or something, we could say, alright, well, our bottom 25% scored a 55, so we're going to make that a C minus instead. Our top 25%, we're going to make the 85 into a 90, and we're going to kind of shift everything that way. Okay? So, this is what we could then do. And actually, IB, I don't know how AP works exactly, but I know IB uses a somewhat similar kind of concept here where they normalize everything so a certain percent of the scores end up being 7s, a certain percent of the scores end up being 1s. And then a certain percent of the scores are 6s and the same percent are 2s. You know, so it makes a nice bell curve in the end. So the majority of people are getting 3s, 4s, and 5s in the middle there. So now you know kind of how that works. And AP does a similar process as well, but theirs is just a 1 through 5 scale instead of 1 through 7. Okay? Now, what I was just describing to you, where we have kind of an equal amount on either end, we have an element of symmetry there. Okay? And that takes us to the concept of a distribution, analyzing a distribution of data and determining is our mean skewed by the data? What do we mean by that? Well, if I look at this data here, you'll notice if I were to kind of trace how our data went, you know, most of it's in the middle. It kind of trails off on both ends. As you look at your box plot, notice the box is basically in the middle. The whiskers are about the same length on both sides. Okay? So it's kind of centered there. And if we were to find the mean of all this data, we would find that it's pretty close to where the median is at 15 here. Alright? Now, it's not necessarily going to be exactly 15, but it's going to be pretty close. Okay? What we have over here with positively skewed data is there are a number of these high scores, but most of our data is down here in the 1, 2, and 3 range. But because we have some scores with higher values, that's going to skew our mean, okay? So our mean, while most of our data is here, and the median is at 3, our mean for this one actually, if I remember correctly, was something like 3.28. All right, so it was somewhere, you know, around here. Okay, now that may not seem like that big of a difference, but when you look at how many scores are down here, okay, you can tell our mean is abnormally high. It's not really a good representation of where our scores are at. Okay, it's just we had a few of them that are really high up here. Okay, this would be like, you know, how many pieces of pizza can you eat in a minute or something, all right? And we have some of these guys who can just pork it down, you know? But most people, if they're lucky, are going to get, you know, 1 or 2, maybe 3, if you're really trying, okay? But it would be skewed high if we had a couple that were really fast eaters or something, okay? Now, here we have kind of the opposite idea. Most of our scores are high, but then we have some really low ones that are going to pull the mean down. Okay? this would be like you've got a team, and most people are performing this well, but you've got some people who are not doing so hot, and they're pulling the entire team down. Okay? And the mean for this one ends up being like around here. Okay? The median was up at 7, but the mean's down here. It's pulled down by these really low scores. Okay? And as you look at the box plot, you can see that how they're skewed, because notice the top 50% is all clustered really pretty close together. And even the top 75% is clustered relatively close together, but then this bottom whisker is really long. Okay? That's what pulls the mean down. Over here with the positively skewed, notice the bottom 50% again was pretty clustered together. Okay? But then we had this really long upper whisker, and that's what skewed, those values are what skewed our mean higher than what really represents our data. Okay? Now, make sure you don't mix these up. Okay? It's how is the mean skewed? Low values, when the majority is high, are going to skew the mean low. A few high values, when the majority of our data is low, is going to skew the mean positively. It's going to make it higher than it ought to be. Okay? All right, so the last thing we want to look at is something we mentioned before, and that is when we have these extreme values, what makes them what we call an outlier? Okay? What makes them an outlier? And what we mean when we're talking about an outlier is some value that is extraordinary. Okay? It is, extraordinary. Beyond what's normal is really what that means. Extra means beyond, ordinary means normal, so what's beyond normal? In other words, it's a piece of data that's a ways away from where most of the data is. Okay? They're either much larger or much smaller than the rest. Okay? If we were looking at like our class averages on the last quiz, okay, a lot of people were kind of clustered around, and then there was one person in 4th period who actually got a perfect score. Okay? That would be the outlier. Okay? The abnormally high score. Thankfully we didn't have any outliers on the bottom end. But anyways, how do we define this? Okay? How do we define this? This is where the IQR comes in handy. We have an upper boundary that kind of defines where our outliers are. And that's found by taking the upper quartile, which is also known as
Q3.
Q3. Okay, so that's Q3. And we're adding to it 1.5 times the IQR. Okay? Now let's stop there for a moment. Notice here, 6.5 is our Q1. Okay? Here, Q3 is 10. So the IQR is 3.5. Okay? So if we take that and we do 1.5 times the IQR, we're going to get 5.25. Okay? So, to determine where that boundary line is, we're going to do Q3 plus 5 1/4. Well, Q3 was 10, right? So 15.25 is the upper boundary. So if I come over here, here's 14, 15, that's 15 and a half. So here's 15.25. Okay? Yeah.
So you always do the 1.5 times IQR first.
Mm-hmm. Yeah. Now, look at this data here. I don't know what all the original data was, but there was evidently our max value ended up being 16. So since 16 is past 15.25, we would call that an outlier. And you can use a little star like they have here, or an asterisk, or you can also, what I usually do, you can also put an X to indicate an outlier. Okay? Now, notice then, we don't draw the whisker going all the way to the boundary line. 14 was the next highest score other than 16. Okay? And since 16 was an outlier, 14 is the next highest score that is not an outlier. So I'm only going to draw my whisker going to there. Okay? Make sense? Alright. Now, the lower boundary. Scroll up just a hair. The lower boundary is the lower quartile, or it's Q1 minus 1.5 times the IQR. Alright? So, we'll use purple here. Okay? So, we have Q1 minus 5.25. Q1 we said was 6.5, so what's our lower boundary? $1.25. Okay? So we come down here, here's 2, here's 1, that's 1.5, so 1.25 is right there. And we just missed it. This value right here at 1 is below 1.25, so our minimum value here is also an outlier. And the next highest score in this set of data must have been a 3. So we draw the whisker to the next score that is not an outlier, 3. Okay?
Wait, but how do you know this?
We would have to have the full set of data. That's how they drew it, so that must be the next highest. Yes?
What if we have more than one outlier?
You can have more than one outlier. Yeah, if we had another one here at a half or something, we would just put another X where it was. Good question. Yeah, you can have more than one outlier. Alright? Now, you don't need to draw these little dotted lines for the boundaries, okay? I did that just so that we can visualize it. You don't have to actually draw it though. You can just put the X's.
Can you scroll up for like a second?
Yeah. Alright, yes,
What
Lori.
if the maximum is equal to the 15.25, is that count as outlier?
No, it has to be past that. Okay, that's a good question. It's any data larger than the upper boundary is an outlier. So, what she was asking is, what if our max value was exactly 15.25? We would just put our point there, draw the whisker to it, it would not be considered an outlier. Okay? So it's got to be past that boundary. Alright, any other questions you guys have? Alright, good. Alright, let's just take a quick practice here. Here we have some bar graphs. and we have some box and whisker plots. And the goal here is to match them together, okay? Now, are there any that jump out of you that seem like they're pretty obvious right away? Santiago?
The B with the 4.
B with 4. Now, what about B, or what about 4 makes you think that that's B?
Because it's like to the left and has like 2 outliers.
Okay. Yeah, most of our data is way over here, right? And then we've got this one real extreme one out here at 13. Okay, so that must be an outlier. This one just happens to be an outlier as well, 9. Okay, but you can see here, most of our data is clustered right down here from 1 to 4. Okay, so here's 1 to 4. All right. So that's where most of the data is, and then we have those couple of outliers. So good. B is 4. What's another one that you can see? Caitlin?
C with 3.
Okay, C is 3. So what makes you think that?
Because you have an outlier of 13, but you also have an outlier of 1.
Okay, good. Yeah, we have one. Now 10 is kind of separated as well, but it's still within the range. Okay, but notice we've got this one extreme value here. Change colors. This one extreme value here and one down here, and notice we ended up with an outlier on either end. Okay, notice to the whiskers, the lowest score other than 1 was a 4, so we drew the whisker going to 4. And here, the next highest whisker, or value after 13 was 10. So we drew this upper whisker only going to 10. Okay? Good, good. So C is 3.
And the D was first one, the one.
Okay, is D the first one, or
Second one.
would A be the first one?
A is the first one.
Okay.
D is kind of like even.
D is kind of even. Yeah, D is really level. Okay. It's pretty symmetric. Okay. A isn't really skewed either. It's pretty symmetric as well. Is there something that could maybe help us be a little more definitive on this, Alexi?
I think that D would be the second one because if you look at it carefully, it's all very, very slightly skewed to the. It's very slightly skewed positively because if you compare the 2 and the 7, there are more 2s than 7s because everything else is even.
Okay. Okay. What do you think, Brian?
The middle range in D is a lot bigger than the middle range in A. So the middle range in like 2 is a lot bigger than the middle range in 1.
Okay, so he's looking at like the middle 50%. The range there from 3 to 6 is broader than here. We're centered a little close, or wait, where are we at? Oh, here. We're centered a little closer with 5 and 6, and it drops off a little more before we get to 4. Okay. And at 3, we're really low. Okay, so we're centered a little tighter in the middle here, as opposed to here, it's spread out a little bit more. Okay? Yeah, Evan?
Also on A, the minimum value is 2, and on the second option, the minimum is 1. So
Okay, there's like the what makes the deal right there. You look at your minimum value, it's a good observation. It only goes down to 2 for A. Here, this one goes all the way down to 1. All right? So all the other observations we made were really good too, and that kind of just confirms the whole idea. So, in this case, D would be 2, and A would be 1. Okay? So you see kind of how these relate to each other? All right. Good. So good observations. Now, there are a couple I want you to try for practice. Okay? They are back in the appendix. If you're having trouble finding them, go to the notes I've posted online. And they're on the last couple pages of the notes. Alright?